All right, welcome to 4.2 Notes. It is Sunday afternoon. Hopefully, you don't mind my casual attire. Just getting out the ball field. But I want to go ahead and get you a video going for tomorrow, which is Monday. All right, so the first thing we're going to do is we need to remember, we learned this in Algebra 1, but we need to remember that when I graph an inequality, that when I have just a less than or greater than, then I'm always going to use a dashed line. And when I have a less than or equal to, or greater than or equal to, I'm always going to use a solid line when I graph these. Okay? And the second other thing I need you to remember or to think back to Algebra 1 and somewhat of a geometry, because you could have covered some of this in geometry as well. But when you want to test a point not on the line, example 0, 0, if it ends up working, then we're going to shade that direction. And if it doesn't work, we're going to shade in the opposite direction. What I mean by that is if I have a line, and let's say I have a positive slope line, and this means I would have had a positive slope line, and I would have been either a less than or equal to or greater than or equal to. If this is a greater than or equal to, and I'm going to write it out here like this, I'm going to shade above the line. I want to be above the line. So if I'm a greater than, then I'm going to go above the line. If I'm the same positive slope line, but this time I was a less than or equal to, I am going to shade below the line for less than or equal to. And conversely, if I have a negative slope line, so I'm going down, and I am greater than or equal to, my greater than or equal to, I'm going to be above the line, so I'm going to be shading above the line. And conversely, if I had a negative slope line, and I was a less than or equal to, less than is going to be below the line. Okay? So that's what I'm kind of talking about in regards to shading. So we know if we have a positive slope line and I'm a greater than, I want to be above that line. If I'm a less than or equal to, I'm going to be below the line. If I have a negative slope line, if I'm greater than, I want to be above the line. And if I have a negative slope line and I have a less than or equal to, I want to be below the line. All right, let's move on. The first one, it says graph the inequality. X is greater than 5. Well, we got to think about what is X being equal to a number? What kind of line is that? Well, that's a vertical line, okay? And it's going to go through the number 5 on the x-axis, but we're just with a greater than. So I want to go ahead and make an open circle because I'm just greater than. And I want a vertical line, which means I can start dashing because I want a dashed line. I got a dashed line. I can put some arrows on my last two dashes. And I want to be greater than that, so I want to be above the line. So I would shade out here. That would be above the line. And that makes sense because what's greater than 5? Well, 6. Well, 5 is here. I'm greater than, so 6 is greater than 5. So that should give you that idea of why I'm shading to the right of the line in this regard. All right, let's do another one. I have y is less than or equal to 2. Y is less than or equal to 2. Well, I know that y equal number is a horizontal line. So in this case, I'm going to be less than or equal to 2. So I'm going to use a solid point because I have that equal to bar underneath. And then I know that it is a horizontal line right through that point. So I'll get this as straight as I possibly can. And the next thing I know is I want to be less than 2. Well, I know that 1 and 0 and -1, all those are less than 2. So when I go to do this, I'm going to shade this direction. So I would shade all of this, and it goes forever and ever and ever. And so that basically tells you that everything below y is less than or equal to 2 would be to make this inequality true. Okay? Moving on. Is this ordered pair a solution to the inequality? Well, you got to think about, what are they asking you here? Is this ordered pair a solution to the inequality? So basically what they're asking is this ordered pair, 7, 3, does this make it true? Make the inequality true. Does it make it true? Does it make it a true statement? Okay? And there's two ways I can do this. There's two ways. Both of them I think are both easy. They're straightforward. The first one is I could graph it. And the second one is plug it in. I could plug the ordered pair in. And if I plug it in, does the inequality become true? Okay? Well, let's graph it. So I know that I have y is less than x minus 1. I know this is in y equals mx plus b form. Okay? Even though we're using inequality, it's still in that form. So I know that the number in front of the x is a 1. Well, that is my slope 1 over 1. My negative 1 or my minus 1 is my y-intercept, my b term. So I know that I can plot that point, negative 1 in. And I want to use a open circle at negative 1. I'm not a closed, I'm an open. And then my slope is 1 over 1. So up 1 over 1. Up 1 over 1. Up 1 over 1. Up 1 over 1. Down 1 to the left 1. Down 1 to the left 1. Because remember, negative and negative makes a positive. Well, I have these, right? So I can start making dashed lines all the way through here. And this would be my line of y is less than x minus 1. Now I can ask myself, is the point 7, 3 less than, or on this side? Well, I want less than, right? So I need to be below the line when I shade. Below the line. So I want to be less than. So I'm going to shade down here. I'm going to leave those numbers so you can see them. Okay, 1, 2, 3, 4, and 5. And really what I'm asking is the point 7, 3 in this shaded area. If it's in this shaded area, then an inequality is true. So I look at this. I'm already at 3 on the y-axis at point 4. So if I keep going to 7, which is going to be off the graph, well, this graph is going up, so I know that the point 7,3 is going to be right in here somewhere. Well, I know that's inside the shaded area, so I know it's true. So this is going to be true, or yes is a solution. So I'm going to use the word yes. It is a solution. Now, I can do it one other way. And that is, I could plug it in. I could plug in 7 in for the x and 3 in for the y and see if it's a true statement. Well, let's do that. So, 3 goes in for y. 7 goes in for the x. And there we go. So it's 3 less than 6. Well, is 3 less than 6? It is. So I know this is a true statement. Well, we can get the same answer doing it either way. Okay? So if they give you a point, on the graph, you can plug it in and see if it's a true statement. All right? Okay, let's move on. Is this ordered pair a solution to the inequality? So once again, is it a true statement? Okay, that's what we want. True statement. All right, so this time I don't have a graph, so I can't just graph it, okay? So what I want to do is I want to plug it in and see if it's a true statement. Well, I've got a 0.45, so I know that I can plug in the 5 in for y greater than 3 times 4 plus 2. Well, 5 greater than 3 times 4 is 12 plus 2. Well, is 5 greater than 14? No, 5 is not greater than 14. So this is not a true statement, right? Not a true statement. So the answer, is this ordered pair a solution to the inequality? Well, the answer is a big fat no. It's not. It's not a solution. Okay? All right. Remember, if I'm going too fast for you, always pause it. Pause it, and then catch back up, start it over, make sure you're doing all that. Okay? Next one, change the standard form equation into slope-intercept form. Slope-intercept form. Well, remember, slope-intercept form is y equals mx plus b. Instead of the equals, we're going to be using inequality signs right now because that's what we're dealing with. But really, it needs to be in this form. Okay? So I look at this, and I have a negative 6x plus 2y equals negative 4. Okay? Well, I want the y by itself on the left-hand side, the x on the other side with the number. Okay? So what I see this is I see a negative 6x. I want to add 6x to both sides because I need to move it. And the opposite of a negative is a positive, so therefore I have to add. What I do to one side of the equation, I must do to the other. And so what I'm left with is a 2y equals 6x minus 4. And I write the x term, the 6x, in front of the number because I want it to look just like the mx plus b. Okay? So now, I have y on the left side by itself, but it's not totally by itself. It's still got a 2 attached to it. Well, in order to get rid of the 2, I must divide. And when I divide on one side, I must divide on the other. And that means every term has to be divided by 2, not just the 6x and not just the 4, but both of them. So this becomes y equals 6x divided by 2 becomes just 3x. Negative 4 divided by 2 becomes negative 2. And therefore, I've changed this standard form equation, negative 6x plus 2y equals negative 4, into slope-intercept form, which is y equals 3x negative 2, or 3x minus 2. All right? Any questions on these, please feel free to ask. I would love to go over this with you. All right? We can move on. The next one, it says graph the solutions to this inequality. Well, basically, I want to graph this inequality. And I see y is less than 3x plus 4. I know this is in y equals mx plus b form or slope-intercept form, so it means I can graph it automatically. I know it's a less than, so I'm going to have an open circle and I'm going to be a dashed line. Okay? And it's at 4, so I'm going to open circle. And my slope is at 3. Well, I can't really go up 3. I can't rise 3 because it'll take me off the graph, so I'm going to have to go down 3. 1, 2, 3. As I go down, my slope is positive, so I've got to go to the left 3 as well. 1, 2, 3. Okay? So I have that. Now you're going to go, wait, Mr. Mosier, you just made a mistake. I'm glad that you caught it. I'm going down 3, but how many am I going left by? You're right, I'm only going 1 over. So we're going to go down 3 and over 1. That was a great catch. I'm glad that you go, wait a second. So look at this again. Here we go. Down 3. 1, 2, 3, over 1. Down 1, 2, 3, over 1. There's my line. I can make dashed lines going through, and there's my line. Now, it is less than. I have a positive slope line, and I want to be less than that, right? I want to be less than. So I cannot be above the line, I got to be below the line. Well, the below the line is going to be which direction? Well, let's think about it for a second, okay? Think about it for a second. One way I can check it, there's an easy way to check. Remember at the beginning I said plug in a 0, 0. and figure it out, right? So let's plug it in. 0 less than 3 times 0 plus 4. Well, that's 0 less than 3 times 0 is 0. All I'm left is 4. Is 0 less than 4? Yes. So I know that the point 0, 0 has to be in the correct side. It has to be in the shaded side. So I know that I'm going to shade below the line. Below the line. That's the easiest way to check when you're doing these. Just plug in 0, 0 and see if it fits. If it doesn't, pick another point and go, I don't know, what about -5, 0? Can I plug that in? Yes. And if it's a true statement, then that's the side you shade. If it's a not true statement, then it's going to be the opposite side. All right, let's do another one. Y is greater than or equal to 1/2 x plus 3. That's y, greater than or equal to 1/2 x plus 3. Well, I know that my y-intercept is +3. I know my inequality is greater than or equal to, so I can do a closed circle. And I want my slope is 1/2, so up 1/2. Down 1/2. Down 1/2. Up 1/2. And I've got my nice line going right through there. It's a solid line because my inequality is an equal to, not a dashed line because it isn't just greater than. It is a greater than or equal to. And I want to be greater. Greater is above the line. So I'm going to go here. Now I know that I can check it. And I'm going to show you how I could check it. What point am I going to use? 0, 0. It's the easiest one. Mathematically, it's going to be the easiest one. Plug a 0 in for y. Great. Greater than or equal to 1/2. Plug a 0 in for x. Well, 0 greater than or equal to 3. No, 0 is not greater than or equal to 3. So I can't shade on this side. So I know that I've shaded correctly. All right. Let's do another one. 4x plus 3y greater than or equal to 6. You're maybe wondering, why did we do that standard form and move it into y equals mx plus b? This is the reason. All right. So I've got 4x plus 3y greater than or equal to 6. I know I need it in y equals mx plus b form. Even though I'm using inequalities, that is the form I need it in. So what does that mean? I got to move this 4x, which means I have to subtract it. It's going to give me 3y greater than or equal to a -4x plus 6. Divide by 3 across the inequality y. Now, since I did not divide by a negative or multiply by a negative, I do not need to flip my inequality sign. It's going to stay the same. So greater than or equal to -4/3x. 6 divided by 3 is 2. So I'm looking for a greater than or equal to, so I know I'm going to have a solid line. My y-intercept is a +2, so I'm going to take my find +2 right there. My slope is a -4/3. So down 4, 1, 2, 3, 4/3, 1, 2, 3. Down 4, 1, 2, 3, 4/3, 1, 2, 3. Up 4, 1, 2, 3, 4. Left 3, 1, 2, 3. Remember, I want it to be a negative slope, so it's going to be going down and to the right. Draw my line. There we go. And there we go. Now, I want to be greater than or equal to. Greater than or equal to, which means I need to be above the line. Well, above the line is going to be up here. above the line, greater than the line. So it's going to be up here. So everything out here is going to make this inequality true. Everything down here is going to make the inequality not true. Okay? And we can see this because I could plug in that magical point, 0, 0. And if I plug 0, 0 in, 0 greater than or equal to negative 4/3 times 0 plus 2. Well, that's 0 greater than. Negative 4/3 times 0 is just 0, leaving me just 2. Is 0 greater than or equal to 2? No, it's not. So I know that it's not a true statement. So I know that this side cannot be shaded. All right. I think our last one coming up. Yep. This is going to be our last one. 4x plus y greater than or equal to 2. I want it in y equals mx plus b form to be able to graph it. So I need to move it out of standard form and into y equals mx plus b, or slope-intercept form. And so what am I going to do? I'm going to subtract 4x, giving me y greater than a negative 4x minus 2. Greater than a negative 4x minus 2. So the first thing I see on this is it's just greater than. So I'm going to have a dashed line. When I graph it, it's going to be a dashed line. My y-intercept is negative 2. Negative 2. And the reason why I have that open circle, just so you remember, is it's not going through that point. I'm going to be greater than that point, right? So that open circle does not include 2. It does not include negative 2 in this case. It's going to be either, well, in this case, it's going to be above, right? Because we're greater than. All right, my slope is a negative 4, which means it's a negative 4 over 1. Down 4, 1, 2, 3, 4 over 1. Up 4, 1, 2, 3, 4, but left. Down 4, 1, 2, 3, 4 over. I can go one more. 1, 2, 3, 4 over. Now I'm doing this because I'm not using a ruler, because if I try to put a ruler on here, it kind of starts messing up my whole thing. And then I want to grab the ruler off of Notability. So I kind of give you more lines so I can graph this easier, freehand. And there we go. My dashed line, my dashed line. Now, I want to be greater than this, right? Greater than, which means I need to be above the line. Well, in case this is above the line, I'm going to be out here, which is going to be above the line, okay? Now, I can check this, once again, by using my 0, 0 point, 0, 0. And 0, 0 should be a true statement. It should be a true statement. Let's plug it in and see. 0 greater than negative 4 times 0 minus 2. 0 greater than negative 4 times 0 is 0. All I'm left with is negative 2. 0 is greater than negative 2. So therefore I know that point is a true, makes my inequality true, and it's right there. All right, have any questions, please feel free to ask. I will be here, and we'll see you tomorrow.